Students, welcome to my channel. In this class, I am going to teach you assignment problem. So, let us solve a problem basing on this assignment. The question is, solve the assignment problem and find the minimum cost of assignment for the payoff matrix. Here, A, B, C, D is given. First, second, third, fourth, fifth is also given, and this is the assignment matrix. So let us solve this problem step by step. So the idea behind this will be more clear to you. Solution. Let us subtract smallest element of each row from every element of the corresponding row. So in the first step, let us subtract smallest element of each row from every element of the corresponding row. We get the following matrix. So here A, B, C, D. Now this is first, second, third, fourth, and fifth. Now the smallest element in the first row is 8. So you have to subtract this 8 from every element of that row. So now 13 minus 8 is 5. 8 minus 8 is 0. 16 minus 8 8. 18 minus 8 10. 19 minus 8 11. Next, let us proceed to the second row. The minimum element in the second row is 9. So let us subtract 9 from every element of the second row. So 9 minus 9 is 0. 15 minus 9 is 6. Then 24 minus 9 is 15. 9 minus 9 is 0. 12 minus 9, 3. Next, third row. So here 4 is the smallest element. Let us subtract 4 from every element of this row. So 12 minus 4 is 8. This is 9 minus 4, 5. This will be 0, then 0, and here we will get 0. Now let us proceed to the fourth row. Here the smallest element is 6. Let us subtract 6 from every element of this row. So it will be 0. 12 minus 6, this is 6. 10 minus 6, 4. 8 minus 6, 2, 13 minus 6, 7. Next, the minimum element is 12. Let us subtract 12 from every element of this row. 15 minus 12 is 3. 17 minus 12 is 5. 18 minus 12 is 6. 12 minus 12, 0. 20 minus 12 is 8. So, our first step is now complete. Let us proceed for the second step. Here, let us subtract smallest element of each column. From every element of corresponding we get the following matrix. This is A, B, C, D, E. A, B, C, D, E. This is first, second, third, fourth, and a fifth. In the first column, we are having the minimum element is 0. So, it will be as such, there will be no change because we have to subtract 0 from every element of first column. So, it will remain as such. Next, we are also having 0. So, there will be no change. 6, 5, this is 6, 5. In the third, we are also having 0. There will be no change. 8, 15, 0, 4, then 6. Next, that column will be also remain same. 0, 0, 2, 0. Next, last one is 0, 7, 8. So, after the second step, we are getting this matrix. So, let us have 0 assignment row wise. So, third step, we are having 0 in cell 1, 2. So, we can have the assignment here now. Next, are having single zero here in this row. First row single zero, here double zero, double zero. Here we are also having single zero. So immediately we have to cross this one. So then zero assignment in cell, this is 1, 2. Next zero assignment in cell, this is 2, 1, 3, 1, 1, 1, 2, 1, 3, 1, 4, 1. Cell 4, 1, 0 assignment. Now, single zero in the fifth row, we are having zero assignment in cell. This is 1, 2, 3, 4, 5, 1, 5, 2, 5, 3, 5, 4. Cell 5, 4. So here we are having zero assignment. So we have to cross the zeros on that column. So let us have in cell 1, 2, then zero assignment in cell 4, 1 and zero assignment in cell 5. After zero assignment row wise, let us proceed to give the zero assignment column wise. Single zero assignment column wise. So in the next step, we have to proceed column wise. Let us have zero assignment. Zero assignment in cell column wise. Here single zero is here in this column. So we can take the assignment here. Single zero, we can take assignment and we will cross this element. So this is the assignment. In cell 3, single zero. Next. So it is not okay. After single zero assignment row wise, then column wise, we get this matrix. But if we clearly observe, we are having no assignment in the second row, and we are also not having assignment in the fifth column. So what do we have to do? So let us see the row in which there is no assignment. So in the second row there is no assignment. So let us have a tick mark here. Let us mark tick in row 2 in which there is no assignment. So we have given tick mark here in row 2, there is no assignment. Mark tick columns 1 and 4 having zeros in marked row 2. So we have a tick mark here, we have a tick mark here. So then we can tick mark in a row 4 and then row 5 having 0 assignments. Mark tick in rows 4 and 5 having assignments in columns 1 and 4. Already marked. So mark tick in rows 4 and 5 having assignments in columns 1 and columns 1 and 4 already marked tick. So that means this here is 4 and this is 5. So now let us draw lines in marked columns. Let us draw lines in marked columns on marked rows. So we have marked columns on the marked rows. So that minimum 4 lines that cover all zeros. Let us draw lines in the marked dotted lines. Let us draw dotted lines in the marked columns and on marked rows so that minimum 4 lines that cover all zeros. So these are marked columns. Now these are unmarked rows. So we are having now dotted lines. Here 3 is the smallest element. Among the numbers that do not have lines. So here 3 the smallest element among the number that do not have lines through them. Three the smallest element among the numbers that do not have lines through them. Now subtracting three from the numbers that do not have lines through them, and adding 3 to those numbers that lies in the intersection of our lines, we get the matrix. So first of all, let us tick mark in the row 2 in which there is no assignment. Now we are having tick mark in the columns 1 and 4 having zeros in the marked rows 2. Rows 2. Now we are having tick mark in the row 4 having assignments in column 1 and 4 already marked. Now let us draw the dotted lines in the marked columns and unmarked rows so that the minimum 4 lines that cover all zeros. Here 3 is the minimum smallest element among the numbers that do not have lines through them. Now subtracting 3 from the numbers that do not have lines through them and adding 3 to those numbers that lies in the intersection of our lines. So we get the matrix CDE, first, second, third, fourth and a fifth. So here we get this is 3, this one is 12, this is 0. Now this will be 4. This will be 3. Now this is 1 and this will be 3 minus 4 and this will be 2, this is 3, this is 5. So we are subtracting 3 from the numbers that do not have lines among them. 6 minus 3, 3, 15 minus 3, 12, 3 minus 3, 0. This is 6 minus 3, 3, 4 minus 3, 1, 7 minus 3, 4, 5 minus 3, 2, 6 minus 3, 3, 8 minus 3, that is 5. Now we have to add 3. So the lines where it has intersection. So here it will be 8. Then in third, it will be 11 plus 3, 8 plus 3. This will be D. So here it will be 13. Now this one will be 3. Here it will be 3. So we get, okay, now subtracting the smallest number 3 from the numbers that do not have line through them and adding 3 to those numbers lies in the intersection of the lines, we get this matrix. So now first 0 assignment row wise, so we can have a single 0, so we'll have this assignment now. So here we are getting assignment in each and every row and each and every column. Now we have complete 0 assignment in its row and also in its column. Then the optimal assignment is, this is first, second, third, fourth and fifth. Now for the first the assignment is B, for the second assignment is E, for the third the assignment is C, fourth IV the assignment is A, and for fifth we have D. So for first it is B, second it is E, third it is C, fourth it is A, and fifth it is E. So now for first B, 0 assignment. So this is 8. Second is E, for second it is E. This is 12. For third it is C, 4. For fourth it is first, that is 6. For fifth it is D, 12. So the total assignment is equal to 8 plus 12, 20, 30, 42. Answer. After getting single row and single column assignment, we find that there was no assignment in row 2 and a column 5. So in order to get that, so we are choosing the row in which there is no assignment. We have to put a tick mark here. Putting tick mark here, we must tick mark the columns in which we are having zeros in row 2. Now, so we are having 2 tick marks in column 2 and a column 3 because they contain zeros in row 1. So then what we have to do? Now let us proceed to column. We find there is an assignment here in row 4. So let us have a tick mark here. Then in column 4, we are having 0 assignment here in row 5. So we are having a tick mark here. After putting tick mark, after that we have to draw the lines column wise having tick mark, row wise having no tick mark. So there are 4 lines we are having here. They cover all zeros. Now the minimum element is 3. So we have to subtract 3 from those numbers having no lines passing through them, and we will add 3 to the numbers lies in the intersection of the line. So after that we get this one. So now we are having only 1 0 here. We can have this 0 assignment when we pass through single 0 assignment row wise. So now we are getting a complete 0 assignment in each row and each column. Then we are comparing this matrix with the original given payoff matrix, and we are getting the optimal assignment. So now on comparison with the given payoff matrix, the assignment for first is B, for second work is E, for third work is C, fourth is A, and fifth is D. The corresponding payoff value is 8, 12, 4, 6, 12. On addition, we are getting 42. So the problem is now solved. The topic for today's class is now completed. I shall meet you with a new topic in my next class. Till then, goodbye.